Imagine that whenever there are two things that are getting closer or getting away from each other, expect that there will be always an outcome out from it, whether the intention is good or not even so good, whether the outcome is good or not so good. And this is also the same when two massive continents move closer, move away, or even slide with each other, and the result or outcome are the formation of volcanoes, mountains, and deep-sea trenches. Before we start our discussion, there are certain words you need to put in mind, and these are tectonic plate, rift valley, subduction, divergent boundary, convergent boundary, transform boundary. Today, we will be discussing about plate boundary and the different plate boundaries and how these boundaries transform geologic features. And these geologic features may include volcanoes, mountains, and deep-sea trenches. And did you know, volcanoes, mountains, and deep-sea trenches form at the boundaries between the plates? Sounds interesting, right? Here is the theory about plate tectonic. The evidence for seafloor spreading suggested that continental and oceanic crust move as enormous slabs, which geologists describe as tectonic plates. Tectonic plates are huge pieces of crust and rigid upper mantle that fit together at their edges to cover Earth's surface. As you can see, there are about 12 major plates and several smaller ones. These plates move very slowly, only a few centimeters each year, which is similar to the rate at which fingernails grow. Plate tectonics is the theory that describes how much tectonic plates move and shape each Earth's surface. They move in different directions at different rates relative to another, and they interact with one another at their boundaries. Each type of boundary has certain geologic characteristics and processes associated with it. Take a look on their differences. A divergent boundary occurs where tectonic plates move away from each other. A convergent boundary occurs where the tectonic plates move toward each other. And a transform boundary occurs where tectonic plates move horizontally past each other. So, let's talk about divergent boundaries. Regions where two tectonic plates are moving apart are called divergent boundaries. Most divergent boundaries are found along the seafloor where they form mid-ocean ranges. The actual plate boundary is located in a fault-bounded valley called a rift, which forms along a range. Throughout million years, the process of seafloor spreading along a divergent boundary can cause an ocean basin to grow wider. Some divergent boundaries form on continents. When continental crust begins to separate, the stretched crust form along narrow depression called a rift valley. The image shows the rift valley that is currently forming in Africa. The rifting might eventually lead to the formation of a new ocean. At convergent boundaries, two tectonic plates are moving toward each other. When two plates collide, the denser plate eventually descends below the other, less dense plate in a process called subduction. There are three types of convergent boundaries, classified according to the type of crust involved. First, we have oceanic. In the oceanic convergent boundary, subduction zone is formed when one oceanic plate, which is denser as a result of cooling, descends below another ocean plate. The process of subduction creates a deep sea trench. The subducted plate descends into the mantle, thereby melting temperature of the plate, causing it to melt. The molten material, called magma, is less dense, so it rises back to the surface, where it often erupts and forms an arc of volcanic islands that parallel the trench. And number two is what we call oceanic continental. Subduction zones are also found where an ocean plate converges with continental plate. Note that it is the denser oceanic plate that is subducted. Oceanic continental convergence also produces a trench and volcanic arc. However, instead of forming an arc of volcanic islands, oceanic continental convergence results in a chain of volcanoes along the edges of continental plate. The result of this type of subduction is a mountain range with many volcanoes. And the third one is the continental. It sounds funny. Third type of convergent boundary forms when two continental plates collide. Continental boundaries form long after an oceanic plate has converged with a continental plate. Recall that the continents are often called along attached to oceanic crust. Over time, an oceanic plate can be completely subducted, dragging an attached continent behind it toward the subduction zone. As a result of its denser composition, oceanic crust descends beneath the continental crust at the subduction zone. The continental crust that is pulled behind it cannot descend because continental rocks are less dense and will not sink into the mantle. As a result, the edges of both continents collide and become crumpled, folded, and uplifted. This forms a vast mountain range, such as the Himalayas. So let's take a look for the third kind of boundaries, and this is the transform boundaries. A region where two plates slide horizontally past each other is a transform boundary. Transform boundaries are characterized by long faults, sometimes hundreds of kilometers in length, and by shallow earthquakes. Transform boundaries were named for the way Earth's crust changes or transforms its relative direction and velocity from one side of the boundary to the other. Recall that new crust is formed at divergent boundaries and destroyed at convergent boundaries. Crust is only deformed or fractured somewhat along time. Crust is only deformed or fractured somewhat along transform boundaries. And for your activity, you're going to make a model ocean basin formation. How did a divergent boundary form at the South Atlantic Ocean? Around 150 million years ago, a divergent boundary split an ancient continent. Over time, new crust was added along the boundary, widening the rift between Africa and South America. Here is the procedure. First, read and complete the lab safety form. Number 2, use a world map to create paper templates of South America and Africa. Place the two continental templates in the center of a large piece of paper and fit them together along the Atlantic coastlines. Number 4, carefully trace around the templates with a pencil. Remove the templates and label the diagram 150 million years ago. And number 5, use of average spreading rate of 4 cm per year at a mapped scale of 1 cm per 500 km to create 6 maps that show the development of the Atlantic Ocean at 30 million year intervals, beginning 150 million years ago. Then after that, you're going to analyze and conclude. First, compare your last map with a world map. Is the actual width of the South Atlantic Ocean the same on both maps? Number 2, consider why there might be differences between the width in your model and the actual width of the present South Atlantic Ocean. And if you're done about all of these things, you're free to move on the next discussion to be given next week.